Okay, solving chemical problems. Most of the problems that we'll have to solve in this chemistry course really can be treated as a unit analysis or a unit conversion problem. It's about converting units. So the approach to solving problems like this is called dimensional analysis. Dimensional analysis is a technique I learned as a junior in high school in physics class. And I think that was probably the most important thing I learned in all of high school, was how to deal with units. When you understand units and how to convert them, you can solve all kinds of problems. It's really a beautiful thing. If you want to succeed in Chem 1A, you have to learn how to do dimensional analysis. Okay? In the worksheet we're doing today, you're going to need to do some dimensional analysis. Some of the problems we do are units and things you're familiar with, and so you might be tempted to solve them a different way. Oh, well, I can just do that one in my head. Don't do it. Things are going to get more complicated, and let's learn the dimensional analysis on a simpler problem so that we can apply it to the ones later where you can't do it in your head. Okay? Important thing. Units should always be included. Okay? Always, always. If the number has a unit, you write it down. It is part of that number. I know it can get tedious. Writing the same thing over and over and over again. Well, taking the class over again because you failed is also tedious, right? Rebuilding that Mars orbiter and coming up with $125 million is also tedious because they forgot to communicate about the inches and the centimeters. Wow. It's really valuable as a teaching tool, but I don't think that was their goal in doing that. So really, really important. Always, always, always write your units. I know some students really hate showing their work. One of my kids is like that, but I could do all the math in my head. There is benefit to being able to write that down. Even if you do the math in your head, you need to be able to write something down to show someone else. It is a valuable skill. So you gotta learn how to do that. Okay, so converting units. There are unit equations and there are conversion factors. A unit equation is just a statement of two equivalent quantities. Here's an example. 2.54 centimeters is equal to 1 inch. These are two different names for the same length. Okay? Most of my kids, we end up calling them by their full name, but my fourth son, his given name is Thomas. We never call him Thomas. We call him Tommy. Thomas and Tommy are two different names for the same person. 1 inch is just a different name for the length that is 2.54 centimeters. They mean the same thing. They are equal. From an equality like that, we can make a conversion factor that allows us to convert from centimeters to inches or from inches to centimeters. And when you learn how to use the units, you don't have to remember, do I multiply or do I divide? The units tell you what to do. So to make a conversion factor, we start with that equality. We need two things that are equal. So I've got 2.5, let's not write with that. 2.54 centimeters is equal to 1 inch. Okay, so that's true. I can make a conversion factor from this. So I'm going to divide both sides it looks like I have three, two visors and one very marginal.
Okay, no lab coats?
I don't see any over there.
Okay, thank you.
Oh, I thought I paused that. Oh, well, that'll be interesting. Okay. What do we do? Well, probably liters in there somewhere would be good, milliliters. So this is where we often overlook. A cubic centimeter is the same as a milliliter. So I can certainly go from cubic centimeters to milliliters. Bless you. Well, I don't remember any of these, and I don't expect you to remember things that I can't remember. We're going to have to go look something up. So the table in the textbook, which is hiding back here on some slide somewhere. I really should put it on that slide, but yeah, whatever. I'm going to find it. Thank you, though. This might cause me to remember. There it is. Okay, so we're doing milliliters and gallons, and so those are volumes. And so we're going to look in the volume column. So here I have the relationship between gallons and liters, and I have liters and quarts. There's different paths that we could take. I think this gallons to liters is going to be the most useful. So 1 gallon, 3.785 liters. 1 gallon equals 3.785. Did I do that right? 875? The short-term memory is the first. 875, right? No.
785.
Isn't that what I had? I don't know. Anyway, after short-term memory, something else goes, but I can't remember what that is. Okay, so gallons and liters, we got that relationship. So sometimes in this path, I'll work forward a little bit, and then I'm kind of stumped, and so then I'll start at the end and work backwards and just keep inching at it until I get something that meets up in the middle. It's like when they build bridges, they don't just start at one end and go straight over to the other. They actually start at both ends and come and meet up in the middle. So if I had liters, I could get to gallons. And so do I know the relationship between milliliters and liters? Yes. It's just that metric prefix. So there, we have a path. That's the hardest part, in my opinion. Figuring out how am I going to get from here to there. Now it's just a matter of doing it. It may be tedious, you may not like it, but it's not actually hard. So 9255 cubic centimeters. 3 arrows, 3 fractions. Cubic centimeters, milliliters, liters, gallons. Same thing. Cubic centimeters, milliliters, liters, gallons. I am just copying down what I figured out. That's all I'm doing. I take this given unit, centimeters cubed, and I'm going to make that the denominator in the next fraction. I'm going to divide by it because I want it to cancel out. Cubic centimeters. And then I take milliliters and put it down here. And then I take liters and put it down there. Okay? Now I put numbers in. Well, this first one is actually the easiest because 1 milliliter is the same as 1 cubic centimeter. So it's just a 1 on the top and a 1 on the bottom. Usually it's not going to be the same number like that, but this one it is. And let's look at this one, liters and milliliters. And this is where I need to have memorized those metric prefixes, and I know that milli stands for 10 to the minus 3. So in the bottom here, I have 1 milliliter. On the top, I have 1. Now I need to write what milli means. I have 1 times 10 to the minus 3 liters. Instead of writing milli like I have in the bottom, I'm writing what it means on the top. Learn the prefixes as they are listed in the table. Never put the prefix with its meaning. and it'll work out all the time. This is not the only way to do it, some of you may say, but I like to do 1 liter is 1,000 milliliters. That works too, but I end up with students telling me the equivalent of 1 inch is 12 feet because they forget which one's bigger. If you follow this pattern of the prefix on one side and it's 10 to the something on the other, you don't have to remember which one's bigger. Gallons and liters. So it was 1 gallon, so I'm going to put 1 in front of gallon, and the 3.785 liters. Any questions? The beauty of YouTube is you can go watch this over and over and over again if you want to. So I start at the left, 9.255 times the top, divide by the bottom, times 1, divide by 1. Times, okay. 1 times 10 to the minus 3. You need to use the scientific notation button on your calculator when you put this in. So that is going to be the EE button or the EXP button. Some of you have a 1 times 10 to the x button. That is not the same as 10 to the x. 10 to the x is something else. So this one, hopefully most of you don't have that. To enter this in scientific notation, you're going to enter 1, and then either EE or EXP, depending on your calculator, and then I'm going to put in the negative sign, not the subtracting sign, but the change sign, and 3. So 1 EE, negative 3, and then multiply by 1 and divide by 3.785. 2.4. Now I can look at this and predict how many significant figures I'm going to need. This has 4. This is exact. That's within the metric system. This is within the metric system. That's exact. Is this exact, gallons to liters? No. This is saying exactly 1 gallon is approximately 3.785 liters. This has 4 sig figs. So I've got 4 and 4. My answer should have 4. So what I want to do is I'm going to keep 2.445. Those are the first 4 significant figures. I'm going to write down at least 2 extras. Sometimes I'll do 3. At least 2 extras. And the unit left standing is gallons. Then I'm going to go back and round this off. 2.445 gallons. The reason I want you to write this down with some extra digits is if I realize later that, oh wait, I rounded that too much, I have the original number here and I can just go back and round it differently. If I round it too much and write it down without the longer version of it, then I have to do the whole calculation over again, and I don't like doing that. Any questions? Other than my son asking if his friend can come over? Now we have to do this. Units raised to a power. Okay. This gives some students just fits. So much trouble with this. Units raised to a power. When you make a conversion factor where you have something like centimeters squared, you take the regular conversion factor and you raise it to the power. The number and the unit. So here's one way of explaining it. So if we want the relationship between square centimeters and square inches, I'm going to start with the relationship between inches and centimeters. And then I'm going to square both sides. I'm going to square the number and I'm going to square the unit. So let me draw you a picture. Here I have a square. Okay, and this side is 1 inch, and this side is 1 inch. What's the area of the square? 1 inch squared. 1 inch times 1 inch, right? So area equals 1 inch times 1 inch, which equals 1 inch squared. Well, what if I measure this in centimeters instead? That side is 2.54 centimeters. And this side is 2.54 centimeters. What's the area in centimeters? Well, it's the length times the width, right? So the area equals 2.54 centimeters times 2.54 centimeters. Well, that equals 6.45 square centimeters. The common mistake that students make is they'll tell me that this area is 2.54 square centimeters. Even the train agrees with me. This is important. When I calculate the area as with one side 2.54, the other side 2.54, the numbers also get squared. Do you see that? So here I've got this side in centimeters and that side in inches. I calculate the area, I square that. I square this. Now this squared means that it's the 2.54 being squared and the centimeter being squared. The 1 gets squared and the inch gets squared. I think part of the problem comes about because 1 squared is still 1. And so this number stays the same. This number changes. Any questions? Those will come up later. Let's do a problem. How many cubic centimeters are there in 2.11 cubic yards? Well, what's the given unit? Cubic yards. So they're giving me 2.11 yards cubed. And what are they asking for? Centimeters cubed. So what I do is I recognize that the relationships between volumes, like cubic yards and cubic centimeters, are related to the relationships between lengths in yards and centimeters. So what I'm first going to do is I'm going to pretend that the cube isn't there. And say, well, how would I do yards to centimeters? Well, we kind of did this the other way around. We did centimeters to yards, didn't we? So we could do yards to inches and then inches to centimeters. Once I have that straight, then I can put the cube back in. I'm doing yards cubed. That means I'm going to get to inches cubed, and I'm going to get to centimeters cubed. So this value here, does that exponent of 3 apply to the 2.11? No, it doesn't. It only applies to the yard. If it applied to the 2.11, it would be 2.11 yards with parentheses around cubed, or it would be 2.11 cubed yards cubed. Not. These are not the same. So some students hear me, oh, you have to cube the unit to the number 2, and then they cube everything. So don't do that. Come on. Let's get rid of that mess. Okay. So now what I'm going to do is I'm going to write my path. Again, just kind of setting the cube aside. And I'll bring it in again at the end. That was the right end. 2.11 yards. And I have 2 arrows. I have 2 conversion factors. I've got inches here, and I've got centimeters there. So the inches are going to be in the bottom, And the yards are going to be in the bottom because I want these guys to cancel out. There's 36 inches in 1 yard. There's 2.54 centimeters in 1 inch. And now I need to bring the cube back. So this was cubed. This whole thing is cubed. This whole thing is cubed. Everything in it. The number on the top, the unit on the top, the number on the bottom, the unit on the bottom. And so some of you may be able to just do it that way and get the correct answer. Some of you might need to write it out so it's a little clearer what you're doing. So you've got 36 cubed, inches cubed, divided by 1 cubed. Well, 1 cubed is just 1. Yards cubed. Times 2.54 cubed, centimeters cubed. Divided by 1 cubed, which is just 1, inches cubed. And then we see the yards cubed cancel, the inches cubed cancel. Any questions?
You had to cube all of it so that you could multiply, so that you could get rid of the cube on the other side.
Mm-hmm. See, if I don't cube the 36, then it's not going to be equal anymore. That's why I drew this square earlier. So if this is 36 inches and 36 inches, the area is not 36 inches squared, right? If I'm doing a volume, it's not 36 inches cubed. It's 36 times 36 times 36 inches cubed. So on your calculator, there's a couple different ways you could do this. My TI-36X Pro has an X to the box button. And so what I do is I do 2.11 times, and then I'm going to put 36, and I'm going to press X to the box, and 3 times 2.54 X to the box, 3 equals. And this ends up being a very large number. 1613210.75 cubic centimeters. Cubic centimeters. Your calculator may have a cube button, or you may just want to multiply by 36 3 times. Whatever you do, as long as you're consistent in getting the correct answer. How many sig figs should my answer have? 3. These conversions are both exact. So I start with 3 sig figs, I end with 3 sig figs. So is that 161 cubic centimeters? Times something, right? Because that is what, 1.6 million cubic centimeters? That doesn't round to 161. That's not even close. I am rounding far to the left of the decimal point. I should put this in scientific notation. 1.61. That's what I'm keeping. And the 3 is going away. It's less times 10 to the. So I'm going to take this decimal point and I'm moving it 1, 2, 3, 4, 5, 6 places. So that's a positive 6 cubic centimeters. Any questions? You feeling okay with the cube units, or you want another example? Another one? Okay, let's do this one. Vineyard has 145 acres of Chardonnay grapes. Particular soil supplement requires 5.50 grams for every square meter of vineyard. How many kilograms of the soil supplement are required for the entire vineyard? Oh, there's a typo in there. Anybody see what the typo is? Acre is a unit of area. Cubic meter is a unit of volume. Come on. I can't erase that. What am I doing? I'm losing my mind. That's supposed to be squared. Come on. Okay, so this one's a little more complicated, isn't it? It's also maybe a practical problem. You could actually run into this. You're, running a vineyard. What do? Pull the numbers and their units out first. So you read through the problem all the way, and then you go back and you pull out the numbers. So the first number I'm coming to is 145 acres. Blah, 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 blah. 5.50 grams for every square meter. Well, I could write that in a couple of different ways. 5.50 grams for every is like per square meter of vineyard. Or you might want to say 5.50 grams equals 1 square meter. And they're asking for kilograms, and then I also have this relationship here. I'm not going to write that down because it's already written out nicely. Okay, so I've got my given values. What am I trying to find? How many kilograms? So kilograms is where I'm going. I'm going to start with one of these. You can only start in one place. I'm going to start in one of these, and I'm going to try to get to kilograms. Okay, so here's where you can kind of hedge your bets or take some kind of shortcuts. So look at the units. 145 acres, that's a single unit. This is one of those compound units. It's grams per square meter. It's relating to different units. Usually that's going to be a conversion factor and not your starting point. So if you're not sure, start with the number that just has a single unit. So I'm going to start with acres. I'm trying to get to kilograms. I maybe didn't give myself enough room. Put it over here. Okay, so I have to figure out how to get from acres to kilograms. I'm going from an area to a mass? What? It's okay. We have some relationships here. This 5.50 tells me a relationship between grams and square meters. Well, I don't have grams or square meters on either end. But this is kilograms. If I had grams, could I get to kilograms? Sure, I know what kilo means. Okay. This relationship is between grams and square meters. So if I had square meters, I could use this as my conversion factor to get to grams. So this one I'm ending up doing a lot of working backwards. Square meters. Acres. I was given this. 247 acres is equal to square kilometers. So that allows me to go from acres to square kilometers. Can I go from square kilometers to square meters? Sure. If I can go from kilometers to meters, I can go from square kilometers to square meters. Any questions? That's the hardest part of this problem. Figuring out how to get from what they gave you to where they want you to end up. So I'm going to do the rest of this fairly quickly. 145 acres. I'm looking at 1, 2, 3, 4. 4 fractions. 2, 3, 4. Acres to square kilometers. To square meters. To grams. To kilograms. I already wrote that down. I'm just copying it. And then I'm going to take the unit in the numerator and put it in the denominator of the next fraction. And And what that does is it causes all the units, except for the desired one, to cancel out. Any questions? Okay, so now I need to put numbers in. Well, I was given this one. That might be easy to start with. 1 square kilometer is 247 acres. So 1 square kilometer, 247 acres. Okay. I was given this one, 5.50 grams, and that one is showing up right here. So this is a conversion factor that was given to you. And sometimes they end up being right side up like this one is. Sometimes they end up being upside down. The units are going to tell you. You get all the units in first and you don't have to worry about it. So 5.50 stays with the unit gram and 1 stays with the square meters. That last one looks relatively easy. I remind myself that kilo means 10 to the third. I have 1 kilogram on the top. That means I have 1 times 10 to the third on the bottom. 1 kilogram equals 1 times 10 to the third grams. And then this is the square, the unit raised to a power. This is where I need to be careful. So I'm first going to think about, well, what if it's meters and kilometers without the square? What does kilo mean? Well, we already did it over here. Kilo means 10 to the third. So if this is 1 kilometer, then this is 1 times 10 to the third meters. But because the unit is squared, the number has to be squared also. That's important. The 1 is squared, but it ends up being the same. Now it's plug and chug on the calculator. 145 divided by 247 times 1 EE3 squared times 5.5 divided by 1 EE3 equals. How many sig figs should this answer have? I think it should have 3. The acres, the acres of land is 3 sig figs. The supplement dosage is 3 sig figs, and the relationship between square kilometers and acres is 3 sig figs. So how many kilograms of fertilizer do I need? I need 3,230. It's better to put it in scientific notation. 3.23 times 10 to the, and I'm moving this 1, 2, 3 places. If you ordered 323 kilograms, your boss is going to be upset with you, because that wasn't enough. You needed 3,000 kilograms. Any questions? Okay, we did a calculation earlier where we calculated density. Sometimes you need to use density to calculate mass or to calculate volume. This can be done using the equation density equals mass or volume. In my experience, though, students make lots of mistakes when they do that. You can also use density as a conversion factor, and then you won't make nearly as many mistakes. So that's what I'd really like you to do, is use the density as a conversion factor. Then you don't have to rearrange that equation. You don't have to let minor algebra mess-ups screw up your answer. So we're going to treat this as dimensional analysis. A drop of gasoline is a mass of 22 milligrams, a density of 0.754 grams per cubic centimeter. What is its volume in cubic centimeters? Well, let's write down the numbers. We've got 22 milligrams. And we've got 0.754 grams per cubic centimeter. And what are they asking us? Volume in cubic centimeters. So I want cubic centimeters. Well, which of these am I going to start with?
The 22 milligrams.
The 22 milligrams. That's my best guess because this is a single unit that cannot be used to convert from one thing to another. This density can be used to convert between mass and volume. So I'm starting with the milligrams. I need to get from milligrams to cubic centimeters. Well, I should probably use this. Some of the problems in 1A, they throw in extra numbers just to mess with you. This one doesn't have extra numbers. I should probably use that number. This relates grams in cubic centimeters. So if I end up with cubic centimeters, I could get there from grams using the density. This density will let me convert from grams to cubic centimeters. Can I go from milligrams to grams? Absolutely. I just need to know what milli means. Okay, so there we go. 22 milligrams, 2 arrows, 2 fractions. Milligrams to grams to cubic centimeters. I put milligrams in the bottom because I want them to cancel out, and I put grams in the bottom because I want them to cancel out. Milligrams and grams, I know that milli means 10 to the minus 3. So here I have 1 milli, and on the top I'm going to have 1 times 10 to the minus 3 because that's what milli means. And this is my density. The number is with grams, so the number is going to go in the bottom. And cubic centimeters is in the top. Some people say, well, I need a number there. Well, it would be 1. 22 times 1 EE minus 3 divided by 0.754 equals, how many sig figs should this have? 2. So these leading zeros, it's 0.029 stuff. 0.029, that's my second sig fig, the last one I want to keep. 1, 7, 8, there's a bunch of other stuff. I don't need any of those. Cubic centimeters. So I'm going to say this is 0.029 cubic centimeters. Any questions? Just want to tell you one thing really quick. What if I'm doing milligrams to kilograms? If you're doing a unit conversion in the metric system and you've got 2 prefixes, you need to do it in 2 steps. So go from milligrams to grams, and then go from grams to kilograms. Go from the unit with a prefix to the unit without the prefix, and then to the unit with a different prefix. There are shortcuts, but most of them will run you off a cliff. So it's better to just get it right the first time.